How's it going, everyone? This is going to be a walkthrough of a hypothesis testing question where we're looking at a claim made about a single sample. So we have a doctor claiming that on average an illness lasts 7 days. And a study of 50 patients showed a recovery time of 6.4 days with a standard deviation of 0.8. And we want to test the doctor's claim using a significance level of 5%. So step 1 in hypothesis testing will be to state the null hypothesis and the alternative hypothesis and which of the two is the claim. Now what the doctor is claiming is that the average, so we're looking at the population mean, is equal to 7, right? They're saying it's 7 days that the illness lasts. And that would be a null hypothesis because it is a statement about the population mean being equal to something. The alternative hypothesis would be that the population mean is not equal to 7. And the doctor's claim is right here. Now we want to find the critical values or critical value. Now in our case here, because our alternative hypothesis is mu being not equal to something, we have two tails, two ways, two directions in which we can reject our null hypothesis. We could end up with a value too big, sufficiently above 7, or a value too small, sufficiently below 7. So our significance level, alpha, is actually cut into 2. So that's going to be 5%, or 0.05 in decimal form, split into 2, 0.025 on one side and 0.025 on the other side. And what else we will need is the degrees of freedom. And our degrees of freedom is our sample size minus 1, 50 minus 1, which is 49. So we'll have to go to the t-table and find a tail size of 0.025 and 49 degrees of freedom, or whatever we can find that's closest to that. So tail size of 0.025 is right here. And if we look for 50 degrees of freedom, 49 degrees of freedom, well, what we actually find on this particular t-table is there is no 49, and the value closest to 49 is 50. So we'll just go with that value. And we end up with a critical t-value of 2.009. That's selecting whatever's closest to 49 degrees of freedom in the leftmost column, and selecting our tail size of 0.025 in the top row. And when we match those up, we get 2.009. So 2.009. Now the t-table will give us the positive value, and it's up to us to know that it is negative to the left of the center and positive to the right of the center. So those are our two critical values bounding our rejection regions. Then the next step is to calculate the test static and to see whether it reaches our critical values or not. So our test static is going to be our sample mean, x bar, minus mu, divided by standard deviation over the square root of n. So our sample mean was 6.4, and our standard deviation was 0.8. We have 50 patients as our sample size, and the assumed population mean, well, that's our null hypothesis. We're assuming that it's equal to 7. That's why we need the null hypothesis to set mu to be equal to something. So we have 6.4 minus 7 on top. And then we have our standard deviation, which was 0.8. And then we divide that by the square root of 50. So we just perform that calculation. 6.4 minus 7 gives us negative 0.6. And 0.8 divided by the square root of 50 gives us approximately 0.113. So when we have negative 0.6 divided by 0.113, we have negative 5.310 approximately. If we were to plot negative 5.310 on our t-scale, it would be way over here, way past negative 2.009. So that certainly reaches and surpasses the critical t-value, which means we do reject our null hypothesis. Now, if you prefer the p-value method, then you'll want to look at positive 5.310 on the t-table, because the t-table only shows us positive values. So if we look for positive 5.310, well, it's not even on the chart. The numbers get bigger as you move closer to the left. So at 50 degrees of freedom, positive 5.310 would be even more to the left of 2.678. And if we bring that up to look at what our p-value would be, well, because we have a two-tailed situation, if we compare it to our row of one-tail sizes, this would actually be half of the p-value. Half of the p-value would be even less than 0.005, which is certainly less than our tail size of 0.025. If you recall, that's our tail size here, 0.025, which is half of our alpha. So if half of our p-value is certainly less than half of our alpha, well, then our p-value is also less than alpha, which will also tell you that we are, in fact, rejecting the null hypothesis. That's if you prefer that method. So, whichever way you go, our null hypothesis is rejected. Now, what does that tell us about the claim? Well, if we look back, the claim was attached to the null hypothesis. So if we're rejecting the null hypothesis, means we're not going with the claim, means rejecting the claim too. So the data does not support the claim. The data does not support the claim that the average is equal to 7. Okay, so the claim is not supported. And that is how you walk through that hypothesis testing question for a single sample. So I hope that helps, and until next time.